7 notes, apply the fundamental theorem of algebra. In 5.6, you learned what the factor and remainder theorems were. And when you had a remainder of 0, you would have been really excited because that was a 0, also known as an x-intercept, a solution, or a root. The fundamental theorem of algebra tells you how many real and non-real zeros that a polynomial will have. A polynomial f of x of degree n has n complex zeros. When I say complex, that means real and imaginary. Some of these zeros may be repeated. So sometimes you will have 4 total zeros, of which x equals 3 and x equals 3. They're called a double solution because they repeat twice. Sometimes it's a triple. The degree of a polynomial is the number of zeros or solutions for that polynomial function. And I've mentioned that before. I mentioned it the first time in section 5.5. So if you look at the degree of the polynomial, that will tell you how many total zeros there will be for that polynomial. So the example 1, or for the first example, how many zeros does the function f of x equals x to the third plus 5x squared plus 4x plus 20 have? Well, you look at the degree. Because these equations are written in standard form, 3 is the largest exponent, so you're going to have a total of 3 zeros. For the second one, 4 is your largest exponent, so there's going to be 4 zeros. Hopefully the pen will write. To find all the zeros of a polynomial, graph the polynomial to find the x-intercepts, which are known as the zeros, and then use synthetic division to find the rest. Well, since you guys don't have access to my graphing calculators, I'm just going to tell you what a couple of the zeros are, just to make it a little easier, and then we'll find the rest by synthetic division. So for this particular problem, there's going to be a total of 4 zeros. And you know that P is -8. So it's going to be plus or just think of it as 8. Don't even worry about the sign. So it's plus or minus 1 times plus or minus 8 and plus or minus 2. 2 times 4 is also 8. So those are all the factors of P. All the factors of Q are the leading coefficient. So Q is only plus or minus 1. So if you divide everything, it's always P over Q. So your list of possible zeros is going to be plus or minus 1, 2, 4, or 8. So it's a total of 8 numbers there because positive and negatives. And I'm going to tell you that x equals -1 is a 0. So in order to, since we know it's a 0, we're going to do that. We're going to use synthetic division. So 1, -6, +7, 6, and -8. And we're going to put 1 down here along the side. Okay, so bring down your 1. 1 times 1 is 1. Add the 2 vertically. Multiply -5 times 1. Add, multiply, add, multiply, and a remainder of 0, which is what we expect because I told you 1 is going to be a 0. So 1 is a 0. And I'm going to go ahead and tell you in advance that -1 is also a 0. So to show that -1 is a 0, you're going to use these brand new numbers on the bottom row to start your synthetic division, just leaving out the 0. And now you're going to test -1. Well, you know the remainder is going to be 0 because I already told you. So you have, bring down your 1, 1 times -1, add these two, multiply, add, multiply, remainder. So -1 is also a 0. So we know x equals 1 and x equals -1 is a 0. We said there are a total of 4 zeros, so we have to find the remainder. If you're left with 2 zeros, you can always factor, use the quadratic formula, or solve by square roots. So we are going to take the last remaining digits, so these right here, that's our quotient, and so that is x squared minus 6x plus 8. Well, why do I go to x squared? Because there's 2 remaining solutions. We already found 2 of them. So set that equal to 0. And that equation could possibly be factorable. Let's see. So b is, never use a quadratic formula unless it's our last resort. So b is -6. A times c is 1 times 8. And then the two factors that multiply give you positive 8 and added give you -6 are -2 and -4. And our last step in solving is to use the zero product property and set both of those equal to 0. So when you set the first expression equal to 0, you get x equals 2 because you'd add 2 to both sides. Here you'd get x equals 4. So here's your remaining zeros. And we found all the zeros. Now, normally, if you had a graphing calculator, you would just type in that equation in your y equals, and it would give you all the zeros on the graph. But we don't have that technology, so we're going to do it the old school way. So let's look at problem number 2. Problem number 2 will also have 4 zeros. And I'm going to tell you that, again, -1 and +1 are going to be 2 of your zeros. So let's just indicate it. I do want to tell you something here. When we're doing synthetic division, you have to be really, really careful. First of all, we're going to have to rewrite this equation. I'll show you why. Okay, so the largest exponent is 4, x to the 4th. But then notice there's an x to the 3rd missing, so you have to put a 0 x to the 3rd placeholder plus 15x squared minus 16. You can't just ignore the fact that there's a missing term, because in synthetic division, that's going to really hurt you if you don't put that. Now, the coefficients of your polynomial are 1, 0, 15, and -16. And I already said -1 is a 0, so let's prove that it is. Bring down the 1. 1 times -1, add negative times the negative, positive, add negative times the positive. Oops, I did something wrong. So let's see. 1. What did I do wrong? I must have done something wrong. Let me just erase this. Let me start with a +1. Not that it should matter. It should not matter at all. But I'm going to try and correct this. So let me just try 1. So 1x to the 4th plus 0x to the 3rd plus 15x squared. Oh, I know what I did wrong. Darn it. Okay. Well, I'm just going to stick it in here because I don't have room. I forgot that there was a plus 0x missing also. So great. So you have 1, 0, 15, 0, and -16. Now the -1 will work. Totally forgot that there were 2 terms missing. So bring down the 1. 1 times -1. Multiply. It's a positive 16. 16 times -1 is -16. And that gives you a remainder of 0. So -1 is a 0. Okay, and so most people just don't even rewrite these again because you're going to use these 4 to do your next one, and we're going to show that 1 is a 0. Just don't draw your line all the way up to that 0. So bring down the 1. 1 times 1 is 1. Add the -1 plus 1. 1 times 0, 0. Add. 16 times 1 is 16. Add. So you're always, and so what's remaining here, this is your quotient. And we already know 2 of the zeros are -1 and +1. So these 2 are your zeros so far that we know. And so since the degree is 4, we are lacking 2 more zeros. So that's the quadratic formula, x factor, or square roots. So let's write our quotient as x squared plus 0x plus 16. When there's a middle term of 0x, you don't want to factor. So you can use the quadratic formula or you can use solving by square roots. I would use solving by square roots. So subtract 16 on both sides. X squared equals negative 16. The 0x is just irrelevant. And now you take the square root of both sides. X equals, whenever you take the square root of both sides, you have that plus or minus. You have the square root of negative 16, so you got to put an I there. And so x equals plus or minus, the square root of 16 is 4, but you have the I, and there you go. So you have plus or minus 4i, so a positive 4i and a negative 4i. And there's your remaining two solutions. So in example number 2, we had 2 real solutions and 2 imaginary solutions, but we still have a total of 4 zeros. Okay, let's do our last one on this page. In this particular example, again, we are going to have 4 zeros. And notice that this particular one is in standard form. This one is a little bit more difficult. Now, I'm going to go ahead and list my P. So P is plus or minus 1 and plus or minus 3. Only 1 times 3 gives us 3. Or negative 1 times a negative 3 gives us 3. Here, we have plus or minus 1. So this is Q. Plus or minus 4 and 2 times 2. So we're not going to write 2 twice. And so now we're going to write our possible zeros to choose from. So that's P divided by Q. So we have divide these two numbers here by 1 first. So that'd just be 1 and 3. So we have 1 plus or minus 1 plus or minus 3. Now take those same two numbers for P and divide each one by 2. So it'd be 1/2 and 3/2. And now take the same two numbers and divide by 4. So you have 1/4 and 3/4. So you have a total of 2, 4, 6, 8, 10, 12 zeros to choose from. But we don't want to be here all day long. And I'm just going to tell you that negative 1/2 is a 0. So let's test that using the synthetic division. So 4, 4, negative 11, it's not missing anything, negative 12, negative 3, and we are going to test a negative 1/2. I already told you it's going to be a 0. Normally we'd look it up in our graphing calculator. Okay, my line's really bothering me. It's crooked. So make it a little bit nicer anyway. There we go. Bring down the first 4. 4 times a negative 1/2 is a negative 2. 4 plus negative 2 is 2. 2 times negative 1/2 is negative 1. Add those two. Negative times negative is a positive. And negative times a negative is a positive. Negative 6 times a negative 1/2 is a positive 3. And that gives you a 0 as a remainder. So negative 1/2 is a 0. Here's something interesting that you can only see on a graphing calculator. And the fact is, negative 1/2 is going to be a repeated solution. It's going to be a double 0. So taking these 4 new numbers, this 4, 2, negative 12, and negative 6, we are going to repeat negative 1/2 is going to be a 0 again. You would know because if you tried it again, the remainder is going to be 0. So bring down the 4. 4 times negative 1/2 is negative 2. 0 times 0, or 0 times negative 1/2 is 0. And a negative 12 times a negative 1/2 is a positive 6. There we go. And, oops. No, I didn't want to erase the entire line, but it's picky, so I just want to draw a line all the way up to there. And so there's our 2 zeros so far. So x equals negative 1/2. Now, do we write it out twice? No. You could if you want to, or you can just say this is a double 0. So it's 2 zeros right there. So if it counts for 2 of them, you still have 2 more. So the 2 more, we can write the quotient. So quotient would be 4x squared plus 0x minus 12. equals 0. So again, you want to solve by square roots. So disregard that. Add 12. Divide by 4. And then take the square root of both sides. Nothing imaginary here. X equals plus or minus the square root of 3. So your other two zeros are a positive square root of 3 and the negative of the square root of 3. Notice the negative stays outside. It's only inside if it were imaginary. So we have 4 zeros right there, a double zero, and then the 2 zeros right there. Right. Rounding out the section on the back page is what is known as the complex conjugates and irrational conjugates theorem. If f, or g, or w, or whatever, is a polynomial function with real coefficients, so real numbers, and a plus bi is an imaginary zero of f, then another zero would be a minus bi. If you remember from a previous section in 4.6, actually, when I first introduced imaginary numbers, I talked about conjugates. So if something is 7 plus 3i, its conjugate is 7 minus 3i. The first number stays the same. The second number, the imaginary part, would be the opposite. So it would also be a 0. So you have two zeros right then and there. Same thing works if it's real. If a plus the square root of b is a real zero of function f, where b is irrational, then a minus the square root of b is also a 0. For the next example, write a polynomial function f of x with the leading coefficient of 2 and the given zeros. So the given zeros are -1, +2, and 3. So 3 repeats twice. So that's a double zero. So there's a total of 4 zeros. And we have to write the equation given that information. So how do we go about doing this? It's not that bad. F of x equals, the leading coefficient is 2, so it goes immediately after the equal sign. Okay, now all of your zeros go in parentheses. So there's 4. It's 1. Actually, there's 4. X is our variable, so x, 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 x. -1 is a 0, so you don't put -1 here. You put its opposite because remember, when you set that equal to 0, you get the 0 that's called -1. Same with the 2. Same with the 3. And 3 is a double zero, so it repeats twice. Now all you have to do is do FOIL twice to multiply things out. So it can get a little hairy, but it's not too bad. So let's do FOIL here, and let's do FOIL there. So FOIL twice. Don't worry about the 2 right now. That's out there. We're going to mess with that at the very end. So let's just put that there. So first times first. So we have x times x is x squared, -2x plus 1x minus 2. So I already did FOIL for the first two binomials. Now I'm going to do FOIL for these two. So we have x times x is x squared, minus 3x. The inners are minus 3x. And -3 times a -3 is a +9. Now we want to simplify everything inside the parentheses. So it's 2 times x squared minus -2x plus 1x is -1x minus 2. And the next one is x squared minus 6x plus 9. Just got to be really careful here. At this point, I would use the box method to multiply the 3 by 3. So you have 3 terms here, 3 terms there. So your size box is going to be a 3 by 3. Oops. Oh, that's a terrible looking box. Terrible, terrible, terrible. It's okay. It's not any better, but it's going to do. Right? So we're going to have x squared minus 1x minus 2. And over here, we're going to have x squared minus 6x plus 9. Notice we still haven't multiplied by that 2 that's outside the parentheses. We'll deal with that later. So here, x squared times x squared is x to the 4th power. X squared times negative 1x is always put the coefficient first, negative 1. Count up the x's that you have. There's 3. And lastly, negative 2x squared. Repeat with the middle row. Put the coefficient first so you don't forget, and then count up your x's. X squared times x is x to the 3rd. Here's negative 1 times a negative 6 is a positive 6. And then you have x to the 2nd. And that is negative times a negative is a positive. Attach the x. Last one, 9x squared. Last row is always usually easy. Negative 9x minus 18. And then combine like terms. So like terms are these two. Those three. Let's see, what's a decent looking color? So hopefully that's not too bright. There we go. And then anything I haven't colored in is not alike. So now we can kind of get this a little nicer looking. So f of x equals, remember we still have the 2 outside. So we have x to the 4th. Then I'm going to combine the yellows. So that's negative 7, x to the 3rd. Please do not add the x to the 3rd and x to the 3rd and call it x to the 6th. Because we don't do it that way when we're combining like terms. The greens, that's 15 minus 2. So positive 13, x to the 2nd. Purple, positive 3x minus 18. Now, the last remaining step is multiply everything by 2. So distribute 2x to the 4th minus 14x to the 3rd plus 26x to the 2nd plus 6x minus 36. And we just wrote a polynomial with a leading coefficient of 2. As you can see, it's out there. And it has the zeros. So just notice how important it is to be able to write something in factored form because it helps you solve and so on. This polynomial right here that we wrote tells us nothing about what the zeros were. We just know what they are because we were given the zeros. Right, and our last one, we're going to do the same thing. We're going to write a polynomial function f of x. This time it has a leading coefficient of 1. And it has these 2 zeros given. So but we know when something is imaginary, there's going to be its conjugate 0. So this particular problem will have 3 zeros. And why would we say 3 zeros? Because immediately when you see a positive 3i, negative 3i is also a 0. But you can't say the same thing for real numbers. If negative 2 is a 0, that doesn't mean that positive 2 is a 0. However, if you had negative the square root of 7, then positive square root of 7 would also be a 0. So it only works for irrational numbers. So writing our equation, f of x equals, put a 1 out here because that's our leading coefficient, and put all your zeros in parentheses, and there's 3. So x, x, x. A negative 2 is a 0, so its factor is x plus 2. Then you have a plus 3i and a minus 3i. Doesn't matter which one you put where. It's all going to get multiplied. So where can we do FOIL? I would use FOIL here with the imaginaries, but I would not use FOIL doing x plus 2 times x plus 3i. So let's just leave. We could disregard the 1 too. We don't need it. So do FOIL here. So that gives us x to the 2nd plus 3ix minus 3ix, which you should be very thankful. That's going to get those cancel to 0. And then a positive 3i times a negative 3i is negative 9i squared. Let's cross out things that cancel so they get out of our face. And it's not depressing to see them. Right, so we have x plus 2 times x squared minus 9i squared, which looks so much better. Hopefully you remember this from section 4.6. Whenever you see an I squared, you replace it with -1. It's things that you just should know. I mean, we just can't forget things in Algebra 2 because they build, and you're just supposed to remember it. The more you use it, the more you remember it. So we are going to replace in the next step the I squared with a -1. And so that's x plus 2 times x squared plus 9. And now you can use FOIL again. Remember, you could make a box for it. It's totally up to you. But you can use FOIL for something where there's 2 terms times 2 terms. You could do a 2 by 2 box, but there's no point when you can use FOIL and it's quicker. So f of x equals x times x squared is x to the third. Your outers is positive 9x. Inners is 2x squared. And last is 2 times 9. And those we cannot combine. I don't see anything alike, but I'm going to just rearrange it so I put them in standard form. So x to the third, biggest exponent first, then 2x squared plus 9x plus 18. Do we have to? No. Does it look better? I think so. I think anything written in a specific way looks better, and it's a lot easier. And so those are your notes for today. Have a great day, Algebra 2 student.